Hello everyone, welcome to the channel TopGate. In this video, we'll discuss the CPU scheduling criteria. So in the previous video, we have seen what is CPU scheduling and what are the kinds of CPU scheduling. So we have already discussed that there is a preemptive scheduling and there is a non-preemptive CPU scheduling. Now in this one, we will see the scheduling criteria. Now what is the scheduling criteria? In the next upcoming videos, we will be discussing about the CPU scheduling algorithms, and those algorithms were developed keeping in mind these 6 scheduling criteria. Fine. So one by one, I'll be telling you what are these CPU scheduling criteria, and they will be used in most of the questions. Fine. So whenever we are solving any numerical based question of CPU scheduling, we will be coming across these 6 scheduling criteria. So the first point, the first scheduling criteria that we have is the CPU burst time, or we can say it is the execution time, or we can say it is a running time. Now what is this CPU burst time? Now CPU burst time, it is the time for which the process is executing on the CPU. Fine. So if you see that process state diagram, when the process comes, it comes to the new state, and from the new state it goes to the ready state, and from the ready state it goes to the running state. Now how it is migrating from one state to another, when it comes to the new state, it tries to acquire the resources it requires for its completion. When its resource requirement is completed, it goes to the ready state, and in the ready state it is now waiting for its turn to be executed. As soon as the CPU scheduler picks that process from the ready queue and sends it to the CPU for execution. So the time for which the process is executing on the CPU is called as the burst time. Fine. Now remember, I told you that the process has 2 works to do. Either it works on the CPU, that is, it is executing on the CPU, and next thing is it also can execute on the input-output devices. So the burst time is only the time for which the process is executing on the CPU and not working on the input-output devices. So if the process switches from the CPU and goes to the waiting state, then that time for which the process is executing the input-output will not be considered in the execution time or the burst time. Fine. So what is the burst time? Burst time is the time for which the process is executing on the CPU. Clear? Next thing, next criteria is the waiting time. Now, the time for which the process wait for its turn to be executed. Now, where the process is waiting, the process is actually waiting in the ready queue. So I told you that when the process migrates from the new state to the ready state, in the ready state, it is now ready to begin the execution. Fine. So it is the process who is wanting to go to the CPU, but since the operating system is not ready, since the scheduler is not ready, so based upon the algorithm that we have chosen, the CPU scheduler will pick that process and then send it to the CPU for execution. So the process is ready. It is waiting for its turn, but then also the OS is not giving it chance to execute on the CPU. So the time for which it is waiting on the RAM for its turn is called as the waiting time. And this waiting time should be as low as possible. Fine. So we should choose the algorithm in such a way that it generates the waiting time to be as low as possible. Clear? So that is the waiting time. Third thing, the third criteria is the arrival time. Now what is arrival time? The time at which the process enters the ready state from the new state. Fine. So this is called as the arrival time. That is when the process migrates from the new state to the ready state. That is when the process comes, it goes to the new state, and in the new state it is trying to acquire the resources for its completion. As soon as its resource requirement is completed, it tells to the OS that now I am ready to begin the execution. I have acquired all my resources. Now at this time, the long-term scheduler picks that process from the new state and sends it to the ready state. Fine. So the arrival time is the time at which the process is migrating from the new state to the ready state. So as soon as it reaches the ready state, that time is called as the arrival time. Clear? Fourth criteria. The fourth criteria is the exit time or the completion time. So as the name says, that it is the time at which the process complete its work and leave the system. So whatever allocation we have done is everything is deallocated, and this process leaves the CPU and leaves the system and goes out, and its work is completed. Fine. So the time at which the process complete its work and exit the system, that is called as the exit time or the completion time. Fifth criteria, it is turnaround time. Turnaround time. Now it is out of these 6 points, this turnaround time, waiting time is very important. That is, in most of the questions they'll ask you what is the waiting time, what is the average waiting time, what is the average turnaround time. CPU burst, that is a very basic thing. That is every question that you'll come across, you'll be having a CPU burst time in that one. So they will give you CPU burst time, they'll give you arrival time, and they will ask you what is the average waiting time, what is the average turnaround time. Fine. So let's see what is turnaround time. Now the turnaround time, it says the time for which the process remains in the system. The process, as soon as it enters the ready state. Now in the ready state, it waits for some time, then it goes to the CPU for execution, then again it goes to the ready state, again it goes to the running state, again to the ready, again to the waiting state, and so on. So it works in the cycle. So the time for which this process remains in the system, that is called as a turnaround time. That is the total burst time, that is the time for which it executed on the CPU, plus the wait time, that is the time for which it remained in the waiting state doing the input output devices. So all will sum up both these times, and that will give you the turnaround time. Clear? Now the last thing, 6.1, it says it's a response time. So what is response time? The time at which the process receives its first response from the CPU. Now that is a very important thing. We should design the algorithm in such a way that the response time of the process should be as low as possible. That is, we will not let the process wait for its very first response in the RAM for a long time. In fact, we'll at least start it for a moment. That is, it will start for the first time, and then again it will go to the waiting state, again it will execute for some time, again go to the waiting state, again goes to the running state, again goes to the waiting state, and so on. So this will work in a cycle. Now the very first time at which the short-term scheduler sends this process to the running state, that time is called as the response time. Clear? So all these criteria we'll be using in the next numerical based question that we'll be discussing in the next videos. So that is all in this one. Thank you so much.